Let's take a look at this question under the eating curve of a substance. Now, from this point, that's the 4 degrees Celsius to this point. So let's say this is point A, point B, point C, point D. Now, the question says should determine the latent heat of vaporization of water. So here, this is the point where we are having a change of phase of the substance. So at this particular point, the water has changed its phase at a constant temperature. So the temperature here is 100. So that means from this point, there is what an equilibrium what temperature. So here we are having our water and what and steam at this particular what point. That's B C. So the heat involved here is the latent heat of what vaporization. Here from A to B, we are having water only. So the heat involved here is of sensible of heat. So from here to here, C to D, we have steam what only. So what happened? So the heat involved here is of is sensible of heat. So that means A to B, we have sensible heat because there is what? There is a change in what? In temperature. B to C, we have what the latent heat, which is the latent of vaporization, because temperature is what is constant as is as ABC. While C to D, we also have the sensible heat because our temperature changes. So there is a change in our temperature. So the question says the latent heat of vaporization. So now if you look at this graph at point B, so you trace down to determine the heat at that point. So this is 8 times 10 per 3. So point C, you trace down. So the value there is 53 times 10 per 3. So here, our Q here equals to the heat here. So let's say this one, we have our Q2 here minus Q1 to find what the heat involved, that was the latent heat of our vaporization. So we now say recall. So recall that our Q here equals to MLB. But this Q here is determined from the graph as our Q2 minus Q1, which is MLB as is as ABC. So they ask us to find LV. So our LV is Q2 minus Q1 over what? The mass of water. So our LV equals to our Q2. This is our Q2, then this one is what? Our Q1. So our Q2 here is 53 times 10 per 3. Our Q1 is 8 times 10 per 3. Then the mass of this substance, which is water, is 0.02 as is at ABC. So what is common? We have 10 per 3, you factorize out. This 53 minus 8, then divided by 0.0 to change to standard form, 2 times 10 per minus 2. Here you have 45 times 10 per 3 over 2 times 10 per minus 3. So to divide this one, 45 over 2 times 10, you have 3. This is minus 2. So the 2 will go all up positive. So we divide this one, you have 22.5 times 10 power 5. In standard form, our LV will now give us 2.25 times 10 raised power 1 plus 5. So the final answer, our LV is 2.25 times 10 raised power 6 joule per kilogram as easy as ABC. That's option what? Option A. This is the Don Tutors where we play with physics. Like this video, share and follow us on all socials. Thank you.